0 is less or equal to t is less or equal to 8, where t is measured in hours. Water is removed from the tank at a rate r of t liters per hour, where r is differentiable and increasing on 0 is less or equal to t is less or equal to 8. At t equals 0, there are 50,000 liters of water in the tank. You should also store W of t into your calculator for future uses. Here are the selected values of r of t. We will be using these values to solve for r prime of 2 in part A. Since 2 is in between 1 and 3, we are going to be using r of 3 minus r of 1 over 3 minus 1. Then we will pull those values from the table. r of 3 is 950 and r of 1 is 1190. Subtract the numbers and your answer will be negative 240 divided by 2. If we simplify, we will get negative 120 liters per hour squared, since r of t is liters per hour and we are dividing by t, which is hours. Part B is asking us to use a left Riemann sum with 4 subintervals to estimate the total amount of water removed from the tank during 8 hours. Again, we will look at our table given. We will multiply the left endpoint to the base, so from 0 to 1 is 1 and the first left endpoint is 1340. From 1 to 3 is 2 and the second left endpoint is 1190. From 3 to 6 is 3 and the third left endpoint is 950. From 6 to 8 is 2 and the last left endpoint is 740. After this, you will add all your products together and your final answer will be 8,050 liters. The problem was asking if it was an over or underestimate. This is an overestimate because we are using the left Riemann sum to estimate a graph that is decreasing. Part C is asking for an estimate of the total amount of water in the tank in the end of 8 hours. At t equals 0, it is 50,000. So it is going to be 50,000 plus the integral from 0 to 8, W of t minus r of t dt. Here's where the answer of part B comes in. Here I am breaking this into 2 integrals, and since we know that r of t is 8,050, instead of writing r of t, I am writing 8,050. So it is going to be 50,000 plus the integral from 0 to 8, Wt dt minus 8,050. We plug it into our calculator and get 49,786 liters. Part D is asking if there is a time t when the rate at which water is pumped and removed at the same time. Here we will let f of t equal W of t and r minus r of t. We're going to be using the intermediate value theorem for this problem. We're going to state that f of t is continuous. Now we will be plugging in 0 and 8 into f of t. So we go back to our calculator and find w of 0 and find r of 0 in the table given. We see that f of 0 is positive and greater than 0. We will continue to do the same thing for f of 8, finding w of 8 in the calculator and r of 8 in the table. F of 8 is negative and less than 0. Since we get a negative value for f of 8, which means we found an interval with a sign change. Since f of t is continuous, f of 8 is less than 0 is less than f of 0. This means that f of t must equal 0 for some t between 0 and 8 by the intermediate value theorem. If f of t equals 0, then w of t minus r of t must equal 0. Then that must mean that w of t equals r of t, since they are both 0. So your explanation for this will be, since f of 8 is a negative and f of 0 is a positive, there is a rate where water is being pumped